Welcome to this comprehensive guide on C# testing, a fundamental and indispensable practice in modern software development. This video will equip you with the knowledge to write robust and reliable C# applications. C# testing is absolutely crucial for ensuring the reliability, stability, and overall functionality of your code, preventing unexpected behaviors and costly errors in production environments. This video will guide beginners through the essential concepts of unit testing, a foundational practice, followed by an introduction to NUnit, a powerful testing framework, and finally, integration testing. These different testing techniques, when applied strategically, work together to ensure all individual components and their interactions within your application function correctly and cohesively, forming a robust system. Unit testing involves testing individual units or components of the code in complete isolation, meaning each part is verified independently without external dependencies interfering. A unit can be a function, a specific method, or an entire class, representing the smallest logically testable part of an application, designed to perform a single, well-defined task. The primary goal of unit testing is to meticulously verify that each isolated unit of the code performs exactly as expected under various predefined conditions and inputs, ensuring its correctness. This process involves creating specific, detailed test cases for each unit, meticulously checking its behavior against expected outcomes, covering both typical and edge scenarios. One significant benefit of unit testing is early bug detection, allowing developers to catch and fix issues at their source long before they escalate into larger, more complex, and costly problems later in the development cycle. Unit testing also significantly simplifies the debugging process, as issues are isolated to smaller, more manageable code segments, making them much easier and faster to pinpoint and resolve. Ultimately, consistent unit testing leads to significantly improved code quality, fostering a more robust, reliable, and easily maintainable codebase that stands the test of time. Testing early in the development process saves considerable time and resources in the long run, preventing the need for costly and time-consuming fixes that often arise much later in the development cycle. To set up a unit testing project in C#, you typically start by creating a new dedicated unit test project directly within your Visual Studio solution, which provides the necessary structure. This involves adding necessary project references to link your test project with your main application project, and then configuring the testing environment to ensure proper execution. Writing a simple unit test in Visual Studio often utilizes the built-in MSDist framework, which is seamlessly integrated, providing a straightforward way to get started with testing. You create a test method, carefully arrange the necessary test data and preconditions, then act by executing the specific method being tested, and finally, assert to verify the expected outcome. Test-driven development, or TDD, is a powerful software development methodology where tests are intentionally written and designed before the actual application code is implemented. This iterative process follows a red-green refactor cycle. First, a failing test is written, then just enough code is added to make it pass, and finally, the code is improved and optimized. NUnit is a widely used and highly popular open-source unit testing framework specifically designed for .NET applications, offering a robust and flexible testing solution. It provides a more flexible and significantly feature-rich environment compared to the default, more basic MSDist framework, making it a preferred choice for many developers. NUnit offers a powerful and extensive set of attributes and assertion methods, enabling developers to write highly robust, expressive, and easily maintainable tests for their C# code. To install NUnit into your project, you typically use the convenient NuGet package manager directly within Visual Studio, which streamlines the installation process. This involves simply searching for and installing the official NUnit NuGet package directly into your unit testing project, which automatically handles dependencies. The basic NUnit test structure includes essential attributes like test, which is used to clearly mark a specific method as an executable test case. Additionally, setup methods are executed automatically before each individual test method runs, allowing for initialization, while teardown methods execute after each test for necessary cleanup. When writing tests with NUnit, You'll extensively use its powerful and varied assertion methods to precisely verify the actual outcomes against your expected results. Key examples include assert that are equal to check if two values are identical, and assert that is true to confirm that a specific Boolean condition evaluates to true. And Unit also robustly supports data-driven tests, a powerful feature enabled by using the test case attribute, which allows for multiple test runs with different data. This allows the same test method to be executed multiple times, each with different input values, significantly enhancing test coverage and reducing redundant code. Common in Unit assertions include assert, that for highly flexible and readable comparisons, assert throws for verifying expected exceptions, and assert contains for efficiently checking collection contents. Integration testing focuses on verifying the interactions and data flow between different units or components of the application, ensuring they work together seamlessly. Its primary purpose is to ensure that these interconnected parts, which may include multiple modules or services, work together correctly and harmoniously as a cohesive and functional system. Integration testing is crucial for uncovering subtle, yet critical issues related to data flow, communication protocols, and interface compatibility between different modules. It also helps identify potential problems with network communication, external API calls, and complex third-party integrations, which unit tests cannot cover. Setting up an integration test environment often requires careful preparation, including creating mock objects, stubs, or dedicated test databases to simulate real dependencies. These simulated components allow you to precisely control external dependencies, ensuring that your tests are focused solely on the interactions being tested rather than external system behavior. Writing integration tests involves thoroughly verifying the complex interaction and data exchange between different classes, modules, or even separate services within your application. This includes rigorously testing database access operations, ensuring that data is correctly stored, updated, and retrieved, and that data integrity is maintained. You'll also test API calls to external services, verifying correct request and response handling and message queue interactions for reliable asynchronous communication between components. Mocking frameworks, such as the popular mock library, are invaluable tools for effectively isolating specific components during integration testing, allowing for focused verification. They allow you to precisely simulate the behavior of real dependencies, such as databases or external APIs, ensuring your tests are focused, reliable, and execute quickly. A key best practice in all forms of testing is to keep your tests strictly independent, meaning each test should not rely on the state or outcome of any other test, ensuring isolation. This independence ensures that tests can be run in any order without side effects, and failures are clearly and unambiguously attributable to a specific, isolated issue. Always strive to write clear, concise, and self-documenting tests that are easy to read and understand, not just for yourself, but for anyone reviewing the code. Avoid introducing unnecessary complexity into your tests. Instead, focus directly on the core logic and behavior that is being tested, keeping them simple and effective. Always test boundary conditions and edge cases thoroughly, as these are often where unexpected behaviors and bugs lurk, ensuring your system is robust at its limits. This includes systematically testing with minimum, maximum, and various invalid input values to ensure your code handles all possible scenarios gracefully. Use descriptive and meaningful test names that clearly articulate precisely what is being tested and the specific expected outcome, improving test readability. Good test names significantly improve readability, making it much easier for developers to quickly understand the purpose of a test and diagnose test failures. Always follow the Arrange Act Assert, or AAA, pattern to structure your tests logically, providing a clear and consistent flow for each test case. First, arrange all necessary test data and preconditions. Then, act by executing the specific code or method being tested. And finally, assert to verify the expected result. Integrate your tests into a continuous integration, or CI, pipeline, which is a critical practice for modern software development workflows. This automatically runs your entire test suite on every code commit, providing immediate and invaluable feedback on any changes, helping to catch regressions early. Code coverage is a valuable metric that measures the percentage of your code base that is actually executed by your test suite, indicating how much of your code is being tested. Specialized tools can help you visualize and track code coverage metrics, effectively identifying areas of your code base that may lack sufficient testing and require attention. Test doubles are generic terms for various types of objects used to replace real dependencies in tests, allowing for isolated and controlled testing environments. They include mocks, which record and verify interactions, stubs, which provide predefined canned responses, and spies, which observe and report on method calls and behavior. Behavior-driven development, or BDD, is an extension of TDD that shifts focus to describing application behavior from a user's perspective using a shared language. BDD uses a ubiquitous, domain-specific language to define tests that clearly describe the expected behavior of the application in a human-readable format, often using Gherkin syntax. Mastering these essential testing techniques will significantly enhance your C# development process, leading to the creation of more reliable, stable, and ultimately higher quality software products. Thank you for joining this comprehensive guide on C# testing. We sincerely hope you now feel confident and well-equipped to implement robust and effective testing in all your C# projects.